In this demo, we'll play the role of a private fund advisory firm that has to report on various regulatory requirements to the SEC for all the funds under our management. We'll show how we can calculate the credit default swap interest for the SEC Form PF, which is one out of hundreds of metrics that we have to report on. Each report has a similar preparation process to generate the data for reporting, which should look something like this. We'll be dealing with two datasets, each with their own unique challenges, that we need to combine in order to calculate the credit default swap metric. These two datasets are the general ledger, or transactions data, and our dividends data. As we open up our transactions dataset, notice the immediate visual feedback we get about our dataset. We're presented with histograms for each column, the data type of that column, and a data quality bar that you can see right here. This lets us know if there are any invalid or missing data in this column. I also want to point out a recent change made to our wrangling experience. We've incorporated natural language into our transformation steps. If we open up the recipe, you'll notice the language in the recipe is easier to interpret. We can toggle between the original wrangle language and then the new natural language. Now, the dataset I'm using has many columns that aren't necessary for my analysis. So let's remove some of the noise from this dataset to make it easier to work with. I'll open up the columns view and click on all of the columns that I'd like to keep. I'll then invert the selection and drop these columns. The Form PF also mandates that we only report on the positive balances. So let's narrow down the values in this balance column. If we click on the drop-down, you'll see our new contextual menus. This allows for quick transformation steps with only a click. We'll go more in depth on this later. If we head into the column details, we'll be presented with some summary statistics of this column and any mismatched values or outliers. We can also see the value histogram showing the range and frequency of the values. I'll go ahead and highlight the positive values in this histogram. And notice as I do this, Trifacta immediately provides me with suggestions on transformations to perform. You'll see these cards, just like the recipe, provide the user with natural language guidance. It turns out that Trifacta's first suggestion, to keep this data, is the correct one, but we want to make a quick modification. Trifacta inferred the range from 0 to the highest value in our dataset, but we'd like to get rid of this upper bound because we'll run future datasets through this recipe, and we want to make sure that we leave the possibility for higher positive values in the future. We've now filtered the transactions to limit it to the structure of the Form PF. I need to calculate the total balance per account, but I also need to keep the transaction details for further calculations. This is something that is very common, however can get a little bit tricky with traditional approaches. I'll click on the account name, the column I want to group by, and also click on the balance column, the column I want aggregated. This aggregation card seems to accomplish what I want, but since it condenses the data into one row per account, I'm losing the other details that I'd like to keep. I'll select this next card, and it looks to achieve what I want, so I'll add that to my recipe. This is a very common task with regulatory reporting data, and we were able to complete it in only a few clicks. Now that we have aggregated the transactions data, we're going to want to transform our dividend dataset so that it matches the structure of our transactions dataset that we just wrangled. Oftentimes, we'll need to pivot data, either transforming columns into rows or rows into columns, to match the formatting of another dataset. We'll show how this can be done in a simple and intuitive manner in Trifacta. I'll switch over to my dividends dataset, and you can see that I've already started to clean up the file. The initial dataset consisted of 167 columns. We removed some of them to keep the 19 columns needed for this report. If we open up the recipe, you can see the steps that have been built thus far, and I can go back in time to see what the dataset looked like before each of these steps. You can see here that we've already built a derived transformation, and if we click Modify, you'll see that what I'm trying to do is to create a conditional function, much like you would see in Excel or other hand tools, that returns a column suggesting to buy when the end quantity is less than or equal to 0, and sell otherwise. This rule-based logic allows the user flexibility to go back and make changes to the transformation process without having to change the subsequent transformations, in addition to providing a paper trail for traceability and repeatability. In order to properly format this dataset, I want to pivot it so that I have a column for the buy values and another column for the sell values. To do this, I'll click on the Buy-Sell column menu, and you'll again see our new contextual menus. These menus provide a wide array of transformation options based on the context of each column. In this case, I'll go down to Restructure and then select Pivot. The default function for a pivot is to count the number of instances of buy and sell, but instead, I want to sum the bond accruals for each category. So I'll browse the possible functions and select Sum, and then browse the columns and select Bond Accrual. Notice how Builder has guided us through this transformation. The last thing to add is I want this column grouped by the instrument currency and also the account, which is represented by the Clear Agent column. Trifacta gives us a preview of this transformation, and you'll see that we now have a sum of the buys and a sum of the sells, so we'll go ahead and add that to our recipe. You'll see that we have some mismatched values in these two new columns. Due to a majority of the rows being zeros, Trifacta inferred integer as the data type, so we'll go ahead and clean that up by selecting decimal instead. In just a couple minutes, we've just properly pivoted our dividend dataset to match the structure of our transactions data. Now that we have both the dividends and transactions data correctly formatted, we want to combine both datasets so that we'll have all the metrics necessary for calculating the credit default swaps. Trifacta provides a join tool for just that. I'll scroll down the list of possible transformations and choose the join tool, and I want to combine my dividend dataset with the transactions dataset. If I click on the join keys, you can see that Trifacta inferred the best columns to join on. In addition to the broker, I want to join on the currency, so I'll press this plus sign, and Trifacta has added the second condition that I want. I'll highlight the columns that I want to keep and add this to my recipe. The SEC is very precise in calculating the credit default swap. We will now apply these calculations to the combined dataset from our transactions and dividends data. In the interest of time, I've already created the credit default swap calculations, but if we look at our recipe, you'll see that it clearly defines each transformation step that we have built. This gives us the confidence we need to apply the recipe again and again to each new future dataset, giving us a repeatable and auditable result. If we find any mistakes, we can easily modify the rules without relying on an army of data engineers. We can also present our process to an auditor who will be able to see how we have generated our results. The next step is to validate our data at scale. You can imagine if the datasets contain millions of rows, traditional methods would get bogged down and sluggish, or would completely crash. This is where we can leverage the power of Hadoop to apply these transformations to datasets of any size. Additionally, Trifacta provides a dashboard that helps users validate their results. You can see the data quality on the whole dataset and on individual columns. When the data is deemed valid, we can then publish the results to a Hive table and automate the entire process to save us enormous amounts of time and resources in the future. When we have finished validating our results, we can hop back to our flow view and trace the steps and recipes taken to get to our results. We can see the original sources, a preview of the file at each stage, the recipes applied, and any joins and unions that have been made. Additionally, we can share our results with others on our team for further validation. This concludes our demo. Thanks for watching.